Here's one about simultaneous equations using the substitution method. So here's the question. This is probably from some preparatory work for methods, or maybe it's a Year 10 student doing a math methods preparation course, but we'll solve it anyway. So solving this simultaneously using the substitution method. So now it says use substitution method, but just to remember what we're actually doing here. So there's these two equations. There is one point that's in common with those two equations. So we're trying to find an x value and a y value that satisfies both of these equations. Okay, so the x's and the y's in both equations, they're going to have the same value for one particular point. So in terms of substitution method, when we look at these two equations, these two expressions for y are the same. So substitution method means this y that's here, instead of writing y, I can replace it or substitute it with 2x plus 24. So equation 1, now instead of having a y on the left hand side, it now has 2x plus 24. And then we can just use equation solving, bring the 2x to the right hand side, bring the 56 to the left hand side, and solve the equation. So tick, we've done the first part of this. We've found the x coordinate of that point or that solution in common to both equations. Now we got to find the y value. So we can choose either equation 1 or equation 2. In this case it doesn't matter because they're both pretty similar. I'll probably choose equation 2 because the numbers are smaller, but generally trying to choose the equation which has the least amount of complexity to substitute back in. So avoiding negative numbers, avoiding fractions if you can. So let's put x equals -8 into equation 2. So there we go, we get y equals 8. And we can state our solution. Some schools or texts prefer that you list it as a point, like x, y equals -8, 8. And if you want to check that your answer is correct, you can substitute those two values into those two equations. Okay, and you'll see that when you put the x and y values into both equations are true. If you try it with any other combination of x and y values, one of those equations won't be true. So hopefully that helps. Good luck solving your simultaneous equations, and good luck on your methods pathway.